Okay, so today we start on a new topic, and these are network theorems. Okay, these are additional tools that will make circuit analysis easier for you to do. No? So we already took up an essential tool, which is nodal analysis. Now we will take up some additional tools. So let me pull up the material that I prepared. Hmm, Having a problem. Just a while. No? Hmm. Yeah, okay, can everybody see my screen? Just give me a thumbs up again. No? Okay. Okay, so this is what I want to cover for today. No, we'll take up the principle of superposition, and then we're going to introduce the concept of equivalence when a circuit contains sources. And then the tool that we will study today with regard to this is source transformation. Okay, if you have any questions, please don't hesitate to shout out your question. Interrupt me, no? If you send me your question by chat, I might not see it right away. No? So I would prefer that you shout it out, no? Sana hindi kayo mahiya. Okay, let's first take up the principle of superposition. Okay, stated, this is how it goes. In a linear electrical circuit containing n independent sources, the current or voltage in any part of the circuit can be expressed as the algebraic sum of n components, each of which is due to each independent source acting alone. It might take you a while to digest that. So, well, to paraphrase that, let's say I have a circuit that contains three independent sources. Note, no? Independent sources, that's very important, no? Very important to take note of. So let's say I have a circuit with three independent sources. Any voltage or current in the circuit can be considered to be the sum of three individual voltages or currents. No? And each individual voltage or current is due to a particular source acting alone. So that is the principle of superposition. Now, this only applies to linear electric circuits. Later on, we're going to come up with a more formal definition of what a linear circuit is. Fortunately, the circuits that we have studied so far, these are your dependent and independent sources plus your resistances. That is a linear circuit. Now, when do you consider a source as acting alone? A source is acting alone if all other sources are suppressed. And how do you suppress a source? No, you suppress a source, or you reduce an independent source to zero by replacing it with a short circuit if that is a voltage source, or replacing it with an open circuit if that is a current source. So when I say suppressed here, that's reducing that source to zero. So again, voltage source, you replace it with a short circuit. Current source, you replace that with an open circuit. So let's jump to an example. Use the principle of superposition to determine I1 and I2 in terms of the circuit parameters. I just want to hear you once in a while, no, just to make sure that you're following me, no. So how many independent sources do I have here? How many? Masyadong obvious, ano? Okay, I only have one person that gave an answer. Okay, you can shout out your answer, no? So anong sinasabi ng principle of superposition? Each current or voltage in the circuit will consist of two components, no? The first component will be due to, let's say, the voltage source acting alone, and the second component will be due to the current source acting alone. And so the total voltage or current will be due to this, will be the sum of those components. So for example, in this particular example, let's consider V of S acting alone. Okay, so what will my circuit look like? My circuit will look like this, no? I have V of S, I have R1, okay, I have R2. What will happen to my current source? My current source, because I want to suppress it, I want to reduce it to zero, will be replaced with an open circuit. So current source replaced by an open circuit. So now I have, let me call this I1A, and let me call this I2A, no? Where I1A and I2A are I1 and I2 due to the voltage source acting alone. Okay, who can tell me, no? What will be the value of I1A and I2A? Anyone? Just shout out. Ano yung magiging value ng I1A and I2A?
VS over R1.
VS over R1, kulang. Kulang.
VS over R1 plus R2 po.
That's right, no? VS over R1 plus R2, no? You have I1A will be equal to I2A, no? Because if this is an open circuit, then this becomes a single loop circuit, no? This becomes a single loop circuit, and therefore the current through R1 and the current through R2 will be the same, no? So I1A will be equal to I2A, which is now going to be VS over R1 plus R2. Okay, that is due to VS acting alone, no? Now let's consider IS acting alone. Let's consider IS acting alone. Okay, so let me draw my equivalent circuit now, no? So I have IS. Okay. I have R2, I2 rather, R2 rather, no? Then I have R1. Okay, what will happen to VS? Anyone? Again, just shout out. What will happen to VS?
Is short po.
Yes, that's right, no? So VS will be a short circuit, no? So VS is replaced by a short circuit, because that's how you reduce a voltage source to zero, by shorting its terminals. So now I will have I1B and I will have I2B, no? Take note that the reference direction of I1 and I2 should be consistent with the reference directions given in the original problem. In other words, if I1 is from left to right, consistently dapat when you consider VS acting alone, it's from left to right. And when you consider IS acting alone, it is also from left to right. Okay. Okay. Who can tell me what the value of I2B is? Oops, sorry about that. What is the value of I2B?
I1B plus I1S.
I2B is, pakiulit,
I1B. I2B equals I1B plus IS.
oh well, yeah, no, you're using KCL, ano? But that doesn't. There's a formula that I can use that will determine I2B from the known elements in the circuit, ano? Tama yung sinabi mo, no? But there's a formula I can use. What's that formula?
I2B.
Sige, go ahead. Sino una?
Ano po sir, I2B is equal to IS multiplied to R1 over R1 plus R2.
That's right, no? This is a current division, remember? Current division special case, no? Pag dalawa lang yung resistor natin, okay? Then if we're getting this current, it's IS multiplied by this resistance divided by the total resistance, no? Okay, so ano yung I1B ngayon? Can somebody else tell me what I1B is? Anyone?
Sir, it's I sub S R2 over R1 plus R2.
Does everybody agree? It's almost correct, no? Ano yung mali? I'm saying it's almost correct, no? There's something wrong.
May negative sign.
Yes, it should be negative, no? Because if we were to follow current division, this current here will flow downward here and will also flow right to left here, no? But take a look at the reference direction here. It's from left to right. So that should be negative, okay? Okay, so now I can now get my total I1 and I2, no? So with both sources, acting, okay, what is I1? I1 is equal to I1A plus I1B, no? Now I1A is equal to VS over R1 plus R2, and then I1B is now minus IS R2 over R1 plus R2. That's I1, no? And then I2 now is I2A plus I2B. Okay, so I2A is I1A VS over R1 plus R2 plus IS R1 over R1 plus R2. Okay. Any questions? Any questions? I hope that's clear. Okay, good. No? I'd appreciate it when I ask something like that, no? Just give me a sign na no? Give me a sign na medyo na intindihan nyo, no? If you don't understand, please interrupt. Okay, so here's another example. Ito medyo mas mahirap-hirap ng konti, no? Determine the current that will flow through the 3 ohm resistor if the switch is in position A. No? Now with the switch transferred to position B, what current will now flow through the 3 ohm resistor? Okay. With the switch in position A, okay, will the 6 ampere source contribute to the current in the 3 ohm resistor? Yes or no?
No po.
Okay, what about the others? Okay, that's correct, no? The answer is no. No? Kasi pag yung switch nandito sa position A, itong current na to, dito lang iikot siya, no? It will only turn around here. It will have no opportunity to go to any other part of the circuit, no? No? Baka sabihin niyo, no? Okay, pagdating dito, hindi ba siya pupunta rito? Well, hindi siya pwedeng pumunta rito kasi wala siyang babalikan dito sa kabila, no? Okay, so with the switch in position A, the 6 ampere source does not contribute to the current that will flow in the 3 ohm resistor. Okay, so what is the equivalent circuit with the switch in position A? No? With the switch in position A, okay, my equivalent circuit is going to be like this. No? I'm going to have my 81 volts, 6 ohms, another 6 ohms here, then I have 12 ohms here, okay, 3 ohms, and I'm trying to determine this, ano? The current through my 3 ohm resistor. No? Okay, let me call this okay, let me call this I of X of A, I's of X of A. The current through my 3 ohm resistor. Okay, what technique can I use to determine I's of X of A? Okay, well, sabihin natin, gamitan natin ng nodal analysis. Okay, so let's use nodal analysis. Okay, so let me make this my reference. Let me make that my reference. Let me call this node X. And what I want to solve for is V's of X. No? I only have 2 essential nodes, so I only have to form one KCL equation. What is going to be my KCL equation? So KCL at V's of X. Okay, so practice din to para sa inyo. Practice din to para sa inyo in doing nodal analysis. You can try to do this in parallel with me, no? Okay, yung current flowing to the right here will just be V's of X over 12 plus 3. Yung current flowing up here will be negative 9. No? Negative 9 because it is flowing into the node. The current flowing through the left here, this one is a little tricky. What is the current flowing through the left there? Can someone tell me?
Sir, is it V of X minus Vx minus 81 volts over 12 ohms?
That's right, no? Very good. No? Vx minus 81 over 12, no? Okay, because in essence, okay, the what you are getting is, okay, ganito na lang, no? These two are in series, no? These two are in series, the 6 and the 6. So I can move this 6 ohms up here, right? Pwede kong itong 6 ohms na to, pwede kong ilipat dito sa taas, dito, ano? And then I can add the 2 6 ohms together, that becomes 12 ohms. No? So you have Vx minus 81 divided by 12, no? Vx minus 81 being the resistance across your 12 ohms. So what is this? Is equal to 0. Okay. Did everybody understand that? Did everybody understand that? I hope so, no? Okay, so one equation, one unknown. We won't go through the solution anymore. I already solved this beforehand. I'm going to get Vx is equal to 105 volts. No? And therefore, what is Ixa? Ixa is now Vx divided by 15. No? This is Vx over 15, Vx divided by 3 plus 12. And this is going to give me 7 amperes. Let me see if there's any question. Okay. Okay. So that is the current that flows through the 3 ampere source. So ito yon. Okay. Let me just call this IX since I already used the term IX, no? That's the current flowing through the 3 ampere source with these two sources acting together. No? So hindi ko ginamitan ng superposition dito sa letter A, ano? I just considered these two sources acting together. Of course, I could have used superposition. Okay. Ano mangyayari ngayon kapag linipat ko yung switch from A to B? I'm going to have a third source, a third independent source that will contribute to the current in the 3 ohm resistor. Okay. However, I already know what the contribution of these two are. No? So ang kukunin ko na lang contribution to determine the total current flowing through the 3 ohm resistor, ang kukunin ko na lang contribution would be of the 6 ampere source. So now what I want to do is I want to consider the 6 ampere source acting alone. No? So with the switch in B, okay, consider the 6 ampere source acting alone. That's what I want to do. What is going to be my equivalent circuit? No? Okay. What will happen to this? Can someone tell me what will happen to this if the 6 ampere source is acting alone?
Shorted.
Yeah, magiging short yan. Ito naman magiging open. Okay. So ang mangyayari, I'm going to have a short here. No? This is my voltage source. Then I have my 6 ohms here. I have my 6 ohms here. This is now open. Okay. I have my 12 ohms here. I have my 3 ohms here. And then I have my 6 ampere source here connected now this way. That's now with the 6 ampere source acting alone. And what I want to compute for is IXB. Kanina IXA, ngayon IXB. What tool can we use to compute for IXB? What technique? Ginamit din natin to kanina. Anyone?
Current division po.
That's right. No? You can again use current division. No? So thank you to those that are trying to answer. No?
Sir,
Yes, no?
may tanong po ako sa PM.
Sorry, again?
May question po ako na sinend to direct message.
Let me check. No? I can't. You said the current source parallel to the 81 volts. Ito yung sa pag-compute ng IXA.
Yes po.
The current source, this one.
Po.
Why is this not in parallel with this?
Dahil sa resistor.
Yeah, remember what we said about two elements being in parallel. Kailangan they share both ends are connected, ano? So for this to be in parallel with this, dapat ito directly nakakabit dito. Saka ito din directly nakakabit diyan. So they're actually not in parallel.
Okay po. Okay po.
So yeah, but yeah, I think akala mo this would be 81 volts, ano?
Medyo po. Yun po yung first tingin ko, kala ko 81 volts na po.
Yeah, just make sure, no, pag nagsosolve ka ng problem, just make sure you recognize when two elements are really in parallel, no. But anyway, thank you for the question. Okay, so balik tayo rito, no. So with the switch in B, okay. So I heard somebody say you can use current division, no. So what is your expression for IXB?
Ano po, sir? IXB equal to 6 amperes
Okay, 6
multiplied to
multiplied by, go.
18 18 ohms over 27 ohms po.
Okay, divided by 18 plus 9, tama, 27. Ah, okay. Medyo, sinong hindi nakasunod doon? No? You all follow that? Yung 18 ohms, okay?
Bakit po 18?
Yeah, that's 6 plus 12, no? Because these two are in series, so that's 18. So, kumbaga, no, IXB times, let's say ito yung R1 mo, 6 plus 12, divided by R1 plus R2, no? R1 is 18, and then R2 is 9. 3 plus 6, 9. So that's 27. Okay. So lalamas, this is going to be 4 amperes. No? So finally, IX will just be equal to IXA plus IXB, which is now 7 plus 4. So this is 11 amperes. Any questions? Okay. Kung may tanong kayo, please don't hesitate. No? Okay. Okay, here. Medyo pahirap ng pahirap yung example natin. Use superposition to solve for V's of O. Asan yung V's of O natin? V's of O natin dito, no? The voltage across the 20 ohm resistor. Okay. How many sources will contribute to this voltage? I just want you to answer that question right now. How many sources will contribute to that voltage?
4.
Okay, I heard 4. Do I hear any other answer?
There are 2 independent sources lang po.
Okay, that's right. Ano? Thank you for answering 4. No? But remember what we said dun sa umpisa? No? Okay. You only consider the independent sources. No? So the reason why I wanted to emphasize that is because a lot of students make that mistake. Ano? They see sources here, and then right away, no, they consider those to be they consider superposition to be applicable to those sources. So we only consider independent sources. So in this particular case, there are only 2 sources that will contribute to the value of V's of O. Okay. So how do we solve this particular problem? No? So there are 2 independent sources. Okay, so let's consider the 10-volt source acting alone. So what will be my equivalent circuit? Well, of course, I'll have the 10 volt. I'll have the 10 volt. Okay. The 5 ohms will be there. Okay. This is my 20 ohms. And let me now call this V's of O A. No? Where V's of O A is the voltage across my 20 ohms with the 10-volt source acting alone. Okay. Now, my dependent sources, I have to I have to include my dependent sources. No? Okay, so this is 0.4 V delta. Okay. That's a dependent current source. This is a dependent voltage source. This is 2 I delta. Where is V delta? V delta is the voltage across my 10 ohm resistor. No? So this is V delta. Actually, if we were to be strict about it, dapat sabihin kong V delta A, no? And I delta A, but hindi naman siguro I don't think it will cause any confusion, ano? So ang I delta natin nandito. This is I delta. What happens to my current source? That will be now an open circuit because I have to suppress my open circuit. Okay. How do you suggest we solve this problem? Well, right now, with the techniques you know, siguro the only technique that you can use to solve this is nodal analysis. So the first thing we do is we select a reference. No? So what if I select this to be my reference? No? So let me choose this as my reference. So how many nodal equations will I have? How many nodal equations will I have? How many essential nodes will there be?
One na
One,
lang
one na lang.
left over.
Careful. No, they're going to be 2. No? They're going to be 2 essential nodes. Actually, sa unang tingin, baka sabihin pa niyo yung 3 eh. No? So this is going to be 1 essential node. Well. Yeah, you're right. Sorry, no? Wala na nakabit dito, no? Yeah, you might consider this to be isang essential node na lang, no? Isang essential node na lang dito. Okay? But there's a problem, no? The problem is ito, okay? Itong VA is the voltage across this element, no? Okay? So it might be helpful for me to define this as a node. Let me just do that. Okay? So that I can get an expression for V's of A, you know? Okay. Anyway, let's go about this, you know? So let me call this X. Let me call that X, no? Okay, so KCL at X. Okay, KCL at X, no? Ano yung current dito palabas dito? Anyone? Here. Okay. That's going to be Vx minus 10 over 5. Right? Okay. And then yung current dito pababa, okay, that's going to be Vx over 20. Okay. And then yung current dito papasok, okay, actually I can already write that as 0.4 V's of A, no? So let me write that as minus 0.4 V's of delta. And that should be equal to 0. Okay. Any question with regard to that? Any question with regard to that? Okay, How many unknowns do I have here?
Dalawa po.
Yeah, I have two unknowns, no? I don't know V's of X. Okay, I don't know V's of X. I also don't know V's of delta. But can I find an expression for V's of delta? I can, ano? Because what is V's of delta? V's of delta is actually, okay, my current flowing here is going to be 0.4 times V's of A. No? But that current is going to be upward dito sa 10 ohm. Right? It's going to be upward dyan sa 10 ohm. So V's of delta is going to be negative 0.4 V's of delta. Okay, that's the current here. Again, this V's of delta is going to be 0.4 V's of delta multiplied by 10 ohms. What's going to happen? Ano mangyayari? What does this tell me? Anybody can see what that tells me? Anong value ng V's of delta?
Zero.
Yeah, that's right, no? Actually, pag ginawa nyo yan, you see that V's of delta is equal to 0. So this is actually equal to 0. So I'm only left with V's of X. No? And if I compute for V's of X, this is V's of X, sorry, V's of X. This is going to be 8 volts. No? Okay. Therefore, V's of O of A is equal to 8 volts. The voltage across the 20 ohms due to the 10 volt source acting alone is going to be equal to 8 volts. Any question with regard to that? Any question?
Sir, pwede ba walk through kung bakit naging 0 si V sub delta ulit?
Oh, okay. This is one loop, di ba? This is one loop. You can see that, ano? Kasi ito open circuit na to, no? Therefore, the current that flows through the 10 ohms is going to be the same as this current. Right? Yung current na dadaan dito will be equal to this particular current, no? So, if I know the current flowing through my 10 ohms, I can compute for this V's of delta. No? So remember that V's of delta is defined as the voltage across my 10 ohm resistor. No? Okay, so what is V's of delta? V's of delta is the current flowing through the 10 ohms, which is negative 0.4 V's of delta. Yan yung current ito, no? Ito yung current flowing through the 10 ohms multiplied by the resistance. Okay, so that means V's of delta is equal to minus 4 V's of delta. How can that be possible unless V's of delta is equal to 0? When is V's of delta equal to minus 4 V's of delta? That can only be possible if V's of delta is equal to 0.
Okay po, thank you.
Okay. So it's unique to this particular circuit. So nagiging 0 to. So matitira na lang itong V's of X, which is the voltage here. Okay. And then if you solve this, you should get, I hope my solution is correct, no? I just did this. That should be equal to 8 volts. So that's with the 10 volt source acting alone, no? Okay, now let's consider the 5 ampere source acting alone. Okay, so now it's going to be a little bit more difficult, ano? So what happens to my voltage source? My voltage source here becomes a short circuit. So meron akong short circuit dito. And then I have my 5 ohms. Okay. I have my 20 ohms here. Okay. Here I have my 0.4 V's of delta. V's of delta. Then I have my 10 ohms here. 10 ohms. Okay, here I have minus plus 2 I's of delta. Ito ngayon yung I's of delta ko, no? I's of delta. And then ngayon, ikakabit ko ngayon yung current source ko, which is my 5 ampere source. Okay, remember my reference is here. This now, I'm going to call this V's of O B. This is the voltage across my 20 ohm resistor with the 5 ampere source acting alone. Okay, this time, how many nodes do I have? How many nodes will I have?
3 is essential nodes,
Yes.
except the reference node.
That's correct, no? Now I have 3 essential nodes with excluding the reference node. Okay, so let me continue to call this X. Let me call this Y. Let me call this Z. No, let me call that Z. Okay, so we do a KCL at X. Okay, so what do I have? Vx over 5. So let's just do this. No? Vx over 5, that's the current flowing right to left dito sa 5 ohms. No?
Sir,
Yes, go ahead.
may question po ako. Di ba sir yung V delta natin, 0 na?
Dito?
Yung nakuha po natin kanina na 0, yung yeah.
Yeah, okay, dito, yes.
Sir, di ba pag 0 yung isang voltage across, parang good as wire na lang yung resistor, so mawawala na po siya?
I wouldn't say good as wire, ano? It's just that walang current na dumadaan, basically. No? If I have a resistor and the voltage across it is 0, all that means is that there's going to be no current flowing.
Okay po.
Is that good?
Yes po.
Sige. Okay. So let's continue here, no? So ito Vx over 5 ohms, okay, plus Vx over 20 ohms, no? So yun yung current naman pababa rito, okay? And then here we have minus 0.4 V delta that is equal to 0. Okay? Okay, then at Y, okay, KCL at Y, okay, I have, let me just consider this current, ano? Itong current na to, no? So what is this going to be? This is going to be 0.4, sorry about this. Tumatalon-talon yung, ano ko, 0.4 V delta, no? That current is right to left here, no, at Y, plus, what is this current going down here?
0.
Well, let's just consider it V delta na lang, ano? V delta. I can actually say Vy minus Vz over 10, ano? I can say Vy minus Vz. Sige, para lang hindi kayo nalito, no? this is going to be yung current pababa dito, hindi zero yan, ano? Remember that yung circuit natin kanina at saka yung circuit natin ngayon ang magkaiba, no? In other words, yung conditions dito are different from the conditions here, no? In other words, just because I saw earlier that V delta was equal to zero, hindi ibig sabihin na V delta is again going to be equal to zero under these conditions, no? So sige, step by step natin, no? So first, this current is 0.4 V delta. And then I have Vy minus Vz over 10. That's the current going down here. Okay. Then what about this? Is this plus or minus?
Plus.
Plus
No, minus, no? Kasi papasok sa y, right? So minus 5 is equal to 0. Okay. Okay. Okay, what is my other equation? What is my other equation? Can I determine V sub z by inspection? Yes, no? What is V sub z?
2I delta po.
2I delta. Okay. Ngayon, ang dami nating unknown, ano? How many unknowns do I have so far? I have Vx, Vy, V sub z, V delta, I delta. Right? So I need two more equations. Can somebody tell me what those two equations will be? First of all, I can get an expression for V delta in terms of Vy and Vz. What is V delta?
Vy minus Vz.
Yeah, that's just Vy minus Vz, no? Okay, what is my other unknown, no? Itong I delta. What is my expression for I delta in terms of my nodal voltages?
Vx over 5.
Careful of the polarity.
Negative Vx over 5.
Right, no? Minus Vx over 5. Okay. Any questions? Again, no? Practice to sa inyo sa nodal analysis. Anyway, what I'm looking for is Vx. If I solve for Vx, no? So solving for Vx, saan yung solution ko dito? Yeah. Just solving for Vx, which is equal to VOB, I'm going to get VOB is going to be equal to 18 volts, no? Sorry. Sorry. 16 volts. No? So just try solving this on your own. Just try solving this system of equations. So VOB is going to be equal to 16 volts. So finally, okay, VO will be equal to VOA plus VOB, which is going to be equal to 24 volts. Okay, are there any questions? I'm taking a look at the chat. Bakit negative yung Vx minus, saan yun, ano? Vx minus 10 over 5? Hindi, no? It's positive. Sorry, that should be colon. I hope that answered the question. Any questions? Any questions? So, kailangan you have to practice, no? Practice solving problems like this, because this is what is going to sharpen your skills in nodal analysis also. Okay, I'm going to leave superposition. No? Again, no? The key takeaway from this example is you can only apply superposition to independent sources. You can only apply superposition to independent sources. So I hope if there's an exam and there are dependent and independent sources, you don't make the mistake of applying superposition even to the dependent sources. There are questions. The book, your textbook, no, Nielsen and Rydell has many practice problems on these. No? So take a look at Nielsen and Rydell. There's a, well, I don't want to advertise it, no, but if you just search the web, there are so many copies of the 9th edition, and the 9th edition is good enough to read. It doesn't really have to be the 10th edition that was recommended. Okay, will there be sample test of the exam? I think I mentioned this already to the class. No, we will give you a lot of example problems, but you should not expect the exam to be the same as the sample problems that are given to you in class, because exams are meant to test, no, your understanding of the concepts. So we will never, it's quite rare that we give a problem na nagbigay kami ng sample problem na ganun sa klase. In other words, we're going to give you a problem that will test whether you understand the basic concepts as applied to that particular problem. So the only way to really study is to practice solving different types of problems. Bakit 16 volts yung VOB? Ano lang, no? Just solve this simultaneously. No? Solve this simultaneously, determine the value of V of X. So hindi ko na pinakita yung solution na yon, no? Because that's no longer an electrical engineering problem. That's just a math problem. No? And then you're going to find that that's going to be equal to 16 volts. Any other questions? Okay, let's move on. No? Equivalent circuits when a circuit has sources. So remember when I talked about equivalence, no? When are two circuits equivalent? No? Kailan nagiging equivalent yung dalawang circuit? Let's say I have a circuit A. I have a circuit A. Let's say this is X and Y. Then I have another circuit B. Okay, and then let's say this is A and B. No? So A and B are equivalent with respect to terminals X and Y and small a and small b if I have a third circuit. Let's say I have a third circuit, circuit C. Kung ito ikabit ko rito, o kaya ito ikabit ko rito, hindi malalaman nitong C, hindi malalaman niya kung ano yung nakakabit sa kanya, whether it is A or B. Okay, you remember that? I explained that. If C has no way of distinguishing whether it is circuit A or circuit B connected to it, then A and B must be equivalent. Yung nararamdaman niya, kung A ang nakakabit sa kanya, parehong-pareho sa nararamdaman niya kung B yung nakakabit sa kanya. No? C cannot distinguish between A and B. No? So that's a concept of equivalence. Now, we already discussed equivalent circuits when your circuits are purely resistive. No? So pinag-usapan na natin yan, ano? If I have a circuit that is purely resistive, let's say this is purely resistive, and I'm only interested in the behavior of this particular circuit with respect to, let's say, terminals X and Y. No? In other words, I'm only interested, no, in the behavior with respect to these two terminals. No? I don't really care what else is happening inside here. If this is purely resistive, ano yung mga tools available? Can you remind me what tools are available to get the equivalent circuit? What are the transformations that you learned? Meron kang series, meron kang parallel, meron kang Y to delta, delta to Y. Okay, I got a good answer from one of you, no? From delta to Y. So those are the tools available, no? Okay. So tools are series connections, parallel connections, and then delta to Y and Y to delta, no? Okay, ang question ngayon, what if this was not purely resistive? What if there were sources in this particular circuit? No? In particular, what if there were dependent and independent sources in this particular circuit? Is there a way of getting an equivalent circuit with respect to A and Y? Okay, we're going to take up three tools. Okay, the first is source transformation. Yun yung kukunin natin today, no? And then the next is Thevenin equivalent. I'm going to take that up starting Thursday. Okay, and then we're going to continue with Thevenin equivalent next week because there are many concepts that are attached to the Thevenin equivalent. And then we're going to take up the Norton equivalent. And then later on, we're going to take up yet another topic, which is maximum power transfer, which is related to Thevenin and Norton equivalent. So yun yung gagawin natin for the rest of this week and also for next week. Okay. So the first thing that we will discuss is source transformation. No? Source transformation. Okay, what is source transformation? If I have an ideal voltage source with a connector connected in series, this can be transformed into an ideal current source with the same resistor connected in parallel, no? And vice versa. No? So what am I saying? No? Here I have an ideal voltage source, and then I have a resistor, which I call RS, that is connected in series to this ideal voltage source. Okay. That can be converted into a current source, I sub S, with the same resistance in parallel to the source. No? Such that this circuit will not be able to distinguish the difference between the left and the right. In other words, this is going to be equivalent to this. And the formula for converting from voltage source to current source is itong IS na to, this IS is just V sub S over R sub S. And if I'm converting from current source to voltage source, itong VS naman na to is just I sub S multiplied by R sub S. Okay, so again, maybe easiest is, first of all, how can we prove this? How can I prove this? The proof is quite easy, no? Okay, dito sa left side, what is my expression for V? This V, no? So the left side, my expression for V is equal to V sub S minus I sub S times R sub S. This voltage is equal to this voltage minus the voltage drop across my series resistance, which is not I of S. I times R of S. No? Not I of S. I times R of S. Okay. Dito naman sa right side, what is my expression for I? No? I consists of two components. No? This component going up, and then subtract from that this current going down. No? So if, in other words, if I do a KCL here, KCL here, okay, what is value of I? I will be equal to I of S minus this current going down, no? Which is equal to V divided by R of S. No? Remember that for the left circuit and the right circuit, V and I should be the same. This V should be the same as this V, and this I should be the same as this I. So if the left circuit and the right circuit are equivalent, I should be able to substitute this I here. No? So anong mangyayari? No? I'm going to get V is equal to Vs, okay, minus, I have Is minus V over Rs multiplied by Rs. Okay. If I do that, no, so this ends up being this ends up being V's of V, no, not V's of S, it's V. No, what I did was this one, sorry. Okay, what I did was this one, I substituted this into this equation. No? So I have V is equal to Vs minus Is minus V over Rs times Rs. No? So this is just going to be equal to Vs minus Is Rs minus V. Okay, and then this cancels out. I'm going to get Vs is equal to Is times Rs. So ito yan, no? And then Is is equal to Vs over Rs. Any questions? Any questions? Okay, so let's take an example. Solve for the power associated with the 6-volt source. Ano yung power associated with this 6-volt source, and indicate whether the source is absorbing or delivering power. If I'm only interested in the power associated with this 6-volt source, I in fact could get an equivalent circuit for the rest of the circuit, ano? So if only interested in the power delivered by the 6-volt source, okay, that means all I have to preserve are the terminals of the 6-volt source, no? Okay, the rest of the circuit can be converted to an equivalent circuit. So what I do, I start from the right, no? I start from the right and work my way toward the left. What can I do with the 40-volt source and the 5-ohm source? What can I do with that? Anyone? Did I lose people? Anong pwede kong gawin dito sa sa dalawang to?
Convert.
Sir,
Convert to, yes, I can convert it to a current source.
Current.
Okay. If I convert that to a current source, then in effect, I'm going to get the equivalent of this, no? I'm getting the equivalent of this. With respect to these two terminals. What is the equivalent of that? The equivalent of that, okay, careful of your direction, no? Will be a current source in parallel with a resistor. What is the value of my resistor? The value of my resistor will still be 5 ohms. What is the value of my current source? Anyone? What will be the value of my current source? Balik tayo rito.
40/5.
Yes, no? The value of my current source is going to be 40/5, which is or 8 amperes. So ito ngayon, pwede kong i-substitute dito, no? By the principle of equivalence. In other words, the top circuit, the one that's dashed, and my current source in parallel with 5 ohms are equivalent. So I can substitute one for the other. So ano mangyayari ngayon? Are there going to be elements that I can combine? I'm
5
now,
ohm.
yeah, I'm now going to have a 5 ohm in parallel with 20 ohm. No? What is that equal to? 5 ohms in parallel with 20.
4 ohms.
4 ohms. That's right. No? So if I do that, what is going to be my new circuit? I'm going to have now a 6-volt source, my 4 ohms, my 30 ohms, my 6 ohms, my 10 ohms, and then dito, I'm going to have 4 ohms, and then 8 amperes. Okay. Where 4 ohms is this 5 ohms in parallel with my 20 ohms. So this is 5 in parallel with 20, which is equal to 4 ohms. Any questions? Any questions so far? Okay. Ano pwede kong gawin next? Any suggestion? What can I do next?
Convert to voltage source para maging series yung 6 and 4.
Yes, that's right. No. So I can now convert this to a voltage source. No. If I convert this to a voltage source, what is this going to be equivalent to? It's going to be, what is the value of the voltage source going to be?
32 volts.
That's right. 32 volts. It's going to be 32 volts in series with 4 ohms. Right. And that 4 ohms is now going to be in series with this 6 ohms and also this 10 ohms. Did you see that? No? Parang ganito, no? Ito yung 6 volts ko. Ito yung 4 ohms ko. Ito yung value to 30 ohms. Okay, I have my 6 ohms here. I have my 10 ohms here. Yeah. And then we said that I now have a 4 ohms and I have now a 32 volts. Right? So parang ganito na lang ngayon yan, no? 6 volts, 4 ohms. Itong tatlo, 6, 4, and 10 are in series. No? Remember what I said about elements in series? you can interchange them in the circuit as long as they're in series, and it's not going to affect how the rest of the circuit behaves, no? And therefore I can actually combine these three, no? This, and this. That's actually what? 20 ohms. No? So here I have 30 ohms. And now here I have 20 ohms. And then my 32 volts. Okay. What can I do next? I think you should be able to see a pattern now, no? What can I do next?
You can convert po ulit sa current source.
Yeah, we can convert this again to a current source, no? So pag kinonvert ko yan sa current source, anong value ng current source na yun? 32 over 20, right? So let's do that here, no? So this is going to be now 6 volts,
1.6 ampere.
1.6. Okay, I will take your word for it. 30 ohms. Yung 20 ohms ngayon will be in parallel. And then this is now going to be 1.6 amperes. So ito ngayon, what is this? Parallel combination of this is 12 ohms, no? 12 ohms. Okay. So finally, what can I do? I can convert again. I convert this again to a voltage source. No? So anong magiging itsura niya? Okay. I have 6 volts. I have 4 ohms. Okay, itong parallel combination na to is 12 ohms. What is the value of my voltage source? What is the value of my voltage source? Anyone? Has anybody answered chat? That's right, no? I saw in the chat. This is going to be 19.2 volts. Simply 1.6 times 12. 1.6 times 12 is 19.2. Okay, so ito, from this, I can already solve for I. I can already solve for I. What is the value of I? I is just now 19.2 minus 6 divided by the total resistance. 12 plus 4, that is 16. And this is going to be 0.825 amperes. So what is the power associated with the 6-volt source? The power associated with the 6-volt, so let me call that P 6 volts, is I multiplied by 6. 0.825 multiplied by 6, okay, which is going to be 4.95 watts. So this is 0.825 multiplied by 6. Is it absorbing or delivering power? Dapat expert na kayo dyan, no?
Absorbing.
Yes, it's absorbing, right? And therefore, if we were to follow the standard convention for the algebraic sign of the power, this is correct, no? Because we said that if power is positive, then that means it's absorbing, no? Because we're basing it on the passive sign convention. So it's absorbing power. Well, it's obvious that it's absorbing power because this voltage is greater than this voltage. And therefore the potential difference, this will be at a higher potential than here, and that's why the current is flowing from right to left. Special cases. I already talked about this in our last meeting. What will happen if I have a resistor that is in parallel with an ideal voltage source? We say that this resistor is not going to affect the circuit that is connected at A and B. It's going to affect the power delivered by V of S, but it is not going to affect the voltages and currents delivered by the circuit connected to A and B. So from the point of view of analysis, okay, we can analyze it using this circuit. No? Basta't hindi natin kino-compute for the power delivered by V of S. I already discussed that last time. Ano? Ganun din dito. No? If I have a resistor in series with an ideal current source, this is not going to affect the voltages and currents of the circuit connected at AB, and therefore ito pwede kong tanggalin, no? When I'm doing my analysis. I just have to put it back if I want to determine the power delivered by I of S. Okay, I have some other examples, but what I'm going to do is, I have one last example, but what I'm going to do is, since we don't have time, I'm going to leave this up to you, no, to solve. Okay, so this is the case where we can simplify the circuit, not only using source conversion, but also using these particular principles, no? Because we're interested in a voltage that is outside the terminals of either my current source or my voltage source. Okay, so I'm going to post these notes now, and the next meetings. So next week I'll introduce Thevenin equivalent, then I'm going to introduce Norton equivalent, and then maximum power transfer. We're going to take these three topics up over the next 3 sessions. Are there any questions? Any questions? No questions?